Hi, my name is Faye, and we're going to be talking about practical psychology today. So, we're going to be talking about experimental designs, and under experimental designs, that these are designs that are used to establish cause and effect relationship. We have the causal inference, internal validity, pre-experimental, experimental, and quasi-experimental designs, and then we have the external validity. Firstly, what is causal inference? This is referred to as the core of experiment, and it refers to the ability to prove one variable, that's the IV, independent variable, to prove that one variable is will cause a change rather in the dependent variable, the DV, in another variable, dependent variable. So I hope we know the difference between causal inference and then correlation, causation and correlation, because if you don't know, just sit back, we'll talk about it. The three conditions that must be met for this causal inference, or the key requirements for a causal inference, are covariance, temporal precedence, and lastly, elimination of alternative explanation. So what covariance is talking about is that cause and effect must correlate, they must have a sort of relationship, they must have some, they must correlate basically, and the two variables must be relatable. Exactly, pardon my word, correlate, they must be relatable in some way, so that when one variable changes, the other variable must also change in a predictable manner. What temporal precedence means is that cause must come before effect, cause must precede effect, and that is IV must come before the DV. In simpler terms, the change in a dependent variable, that's the cause, presumed cause, must happen before the change in the dependent variable, which is the presumed effect. Now, for elimination of alternative explanation, no third variable should be involved. Confounding, extraneous, all those variables should be out. They shouldn't be involved in during this experiment. Then the difference, let me quickly run through differences between causation and correlation. For correlation, it's a statistical relationship between two variables that when one changes, the other tends to change too. But for causation, one variable directly causes a change in another variable. Another thing in another difference between causation and correlation is that you ask the question in correlation that does these variables, do they move together? But in causation, you ask the question of, does X cause change in Y? Like, what is the cause and the effect? Does X cause a change in Y? Then the nature of relationship in correlation can be positive, zero, or negative. While the way causation is referred to or is done is that IV directly influences DV. IV here means independent variable, DV means dependent variable. So for the direction of influence, there's no clear direction in correlation. A may cause B, B may cause A, and even a third factor might cause both of them. But here in causation, there is a clear cause and effect direction where IV is the cause, independent variable is the cause, and dependent variable is the effect. Also, you study correlational research by surveys, observational studies, while you use experimental research to study causation. So controlled experiments with random selection is what you use for causation. Lastly, correlation helps predict trends but does not explain why. However, causation predicts or allows prediction and also gives explanation for these predictions. So correlation does not always imply, or correlation does not imply causation. However, causation usually sometimes implies correlation. Only experiments prove correlation, and anywhere you see random selection plus manipulation of independent variable, it will most likely be a study or a causal study. It will most likely be for a causal study. Now let's go to internal validity. This is you making sure that the experiment proves what you claim it is going to prove. So now, how well does your study prove causality? And this refers to how well an experiment controls confounding variables and isolate only the causal relationship. In much simpler terms, this means that internal validity is about making sure that your experiment is fair and only test one thing at a time, so that you know the real cause of your results. You don't want to test for something and there are extraneous variables, like factors that clearly distorts your experiment is there and you're not controlling it or you're not taking it into consideration. That means your cause of it or your results will be skewed. So the threats to internal validity, there are several threats, but the few that we mentioned in history as the external events affecting the participants, research reactivity, statistical regression, maturation, which is also passage of time. So for passage of time, natural changes can occur in participants over time. Then testing effects, participants might improve because they already took a pre-test, they already know about the test, so you know. Then selection bias, there can be differences in groups, in present groups or before the experiment starts. Then we have um attrition, which means that participants can drop out or can choose to drop out and affect results. This particular one, attrition, is also known as experimental mortality. So for experimental designs now, that's the pretest, experimental and the quasi-experimental. These designs manipulate the independent variable because and use random selection to control for confounding variables, and it allows comparisons between control group and experimental group. So the first one here is pre-experimental designs, and there are two types of experimental designs. There's the one short case study. It's not short as in short at all, it's short as in short, like SHOT. So one short case study, and this applies to treatment to one group and observes the outcome. There's no comparison, you're only applying remember the X and O slides that we have, where X means the introduction of the stimulus, intervention, or the treatment. Then O is the observation or measurement, while R is the random selection or the random assignment. So for one short case study, the X and the O, that's all. XO, that's what it is. And this means that your stimulus is introduced and then it is observed. So observation comes only after stimulus has been introduced, only after intervention has been introduced, only after treatment has been introduced. That's when observation comes. That's for the one short case study. There is no comparison anywhere. Then for the one group pre-test post-test design, I'll say that again. One group pre-test post-test design. This measures a single group before and after a treatment or stimulus has been introduced, and there is no control group here. So now you're observing first, that's the O comes first, then the X next, and then another O after. You know that X is the introduction of stimulus, intervention, or whatever it is you're doing. So like that X is the main experiment, it comes OXO. That is the one group, pre-test O, post-test. You know the test now is X sort of. So OXO, that's for the second one. Now, a major threat to internal validity is that there's no way to know if the effect was due to IV or other factors. You know, there's no control group in one and there's no comparison in the other. So we are not sure if it is what we are doing, if what in manipulation of the IV is what is causing the DV to change, or there's something else that we are not putting into consideration. So for the experimental designs, these are called true experiment or true experimental designs. Three criteria must be met, right? It's random selection. All the time you have to use choose by random selection. Then must have experimental and a control group. You can't just do pretest that will not have any control group. You have to have an experimental group and a control group. Then compare changes between these groups. When all these three criteria have been met, that is when you have successfully done an experimental, a true experimental design. Now, the types of experimental designs, there are three, but we are focusing on two for our level. I'll just briefly mention the third one. So the first one now, remember our RXO, R random selection, X the introduction of stimulus, intervention, then O is the observation. So the types of experimental design or true experimental design is the number one, pre-test, post-test, control group design. I'll take that again. Pre-test, post-test, control group design. And this is a classic experimental design. This is like a main one, like an original one you get. So it goes ROXO, and then RO and another O. So it is ROXO. That's how I used to, remember. For pre-test post-test control group design in experimental designs, we have the ROXO, RO, random selection first, observe, introduce the stimuli, then observe. Then the other group, you'd randomly select, you observe. You are not administering any stimulus this time around, but you are observing after. So the experimental group is the ROXO, and then the control group is the ROO, because there's no introduction. You're trying to compare both the experimental group and the control group. For the second type of true experimental design, we have the post-test only control group design. Post-test only control group design. So here we are talking about the control group, and you're administering after randomly selecting, of course, R, then introduce your stimulus X, then you observe. Then the second one, experimental group, there's always experimental group and control group. The second one is now R, no introduction, and then observe. So you are going to RXO and then RO. The difference, if you play the videos back and forth, you should see the little difference between the first and the second. The third one is factorial design, which examines two or more independent variables and their interaction. It's not in our material, but it's just a third one to take note of if you want to. So the strength of experimental design is that it has high causal validity, because causality, causal inferences, or causality is stating that, or causal validity rather, is saying that this cause and effect thing, is it really what is causing it? Is this really the IV that is causing the DV? So this experimental designs allows us to be sure that, oh yes, this is it. So high causal validity validates the causalness. Then there is an adequate control over variables and replicability. You can adequately control, of course, these things are controlled experiments, so you can control variables. Then the weakness of this particular design, it is artificiality and low external validity. Because it's done in a controlled environment like a lab, it might not be the same effect to have as in a real life scenario, or like real world. So also ethical and practical constraints are quite a problem in this group, because it's not everything you can test for. If you want to test for abuse, will you now deliberately subject somebody to abuse because you want to test for the psychological effect of abuse? No. So these are the weaknesses or the disadvantages of using this group. Now the quasi-experimental design, this one you're not using any random selection at all. No random selection. That is the first thing you should note. And then the designs lack random selection, I've said that, or assignment, making them weaker for causal inference, but still useful in real world setting. So there are two types. The first one, non-equivalent comparison group design. Non-equivalent comparison group design. And the first thing, because there's no R involved here, it is OXO. That's the first one. And then the next group, you're just doing OO and not introducing any stimulus to them. So it compares pre-existing groups, e.g. two different groups. It compares pre-existing groups. And then the time series design, this observes a group multiple times before and after intervention. So yeah, instead of doing OXO, XO, all those ones, you're now doing OOOOX, then OOOOO. So you're doing several or multiple observation of a group before and after you introduce the stimulus or intervention. So the X remains the intervention or the stimulus. So let's just say you're using like five times you observe a group, then you introduce the stimulus, and you still observe them after introduction of stimulus 5 times again. So the advantages of quasi-experiments are it is stronger than pre-experimental designs, but it is weaker than true experiments. This is of course this is due to not randomly selecting your participants. Then disadvantage is that it has a threat to internal validity, because group may differ before or after treatment. So the group might be different. Maybe taking it might have led them to act different or feel different, you know. Then we have external validity. Generalizability of external validity refers to how well your results apply to real world settings. Now, you've done everything in the lab, you've done different places, you've collected like a lot of data. How does your results now apply in the real world? Because everything we do in psychology is to prove that different phenomenon or phenomena can, you know, can be applied into real world scenarios. So how well can your results apply to real world? The threats to external validity are sample bias. If the sample is not properly representative or represented, results may not be generalizable. There can be there's artificial settings involved, so highly controlled lab settings may not reflect real life behavior. Now, a major threat to external validity is Hawthorne effect. Hawthorne, Hawthorne. Hawthorne. That's Hawthorne effect. And this means that participants may change behavior because they know they are being studied. Now, field experiments improve external validity because they can occur, because they occur in real life settings. So that's an advantage of field experiment. However, if there is external validity, there might be low internal validity. So that's it about experimental designs. Thank you.